Hello physics. Here we are starting experiment 1 from circuits, and to start with we're just looking at some of the symbols that are used in drawing our circuits. A wire, it's focusing especially on the skinny part here, that is the connector, and then this might be the insulator. So for example, you can see in this wire here you've got the insulator, the fatter part, and then the bare wire. It's the skinnier part, and that's what they're trying to draw here. A switch is just simply something that can be opened and closed to break the circuit or connect the circuit. A battery, resistor, a light, which may look different a little bit than some others that you might have seen. Some of the others will have a circle with a resistor inside because a light bulb is a resistor. And a fuse, which we won't talk much about. So for this lab, we're going to follow these instructions, and here is the first instruction. This is the sheet that we're going to fill out, and as we get to each question, we'll show you what to do, and as you get to the end of it, you might want to pause the video so that you can take the moment and fill out that part, and then once you've filled the question in, start the video again to watch to fill out the next part, and so on down the lab. All right, let's get started. So the first thing says use 2 pieces of wire to make a connection between springs of one of the light bulbs to the springs of the D cells in such a way that the light will glow. So we're going to use this circuit board, and these batteries is what we're going to use. You can see that this set here we have not replaced the batteries for a long time. Some of you might not even have been born yet when this battery was purchased and put in here, because it says it's best if used by 2002. So it's older than 2002. I don't know what the purchase date is. So it's been around for a little while, and so they can last a long time. This one probably doesn't have a whole lot of life left in it, but we're going to use it anyway. And one way we can check if it has life in it is to use a tester. And you can see that if we touch, first if we turn it on, if I touch to each side of the battery, it shows 1.4 volts. When it's fully charged, it might be 1.5. Most any chemical battery is only 1.5 volts at its maximum. So there's still some life left in these guys, and we're going to use them. So it tells us, first of all, to connect our batteries so that the light bulb will shine. So the way we connect them is these little springs here make it easy to attach a wire in, and underneath this circuit board are the connections, so that if we touch this goes to the battery on this side and so forth. So we don't have to worry about making those connections. They're kind of being made for us if we just put it where it says to put it. So we're going to put it on here, and we'll see if we can get this light bulb to light. Ta-da! So we have made a circuit for a light bulb, and now we want to draw that circuit. So it says draw a circuit with one light bulb. All right, well, we were told that the symbol for light bulb is a circle. I rather draw it with a zigzag pattern in it. That's fine. And then that was connected by some wires to the battery, which we were told was a symbol like this, and we made it go to there. So that's how we might draw a circuit for a battery with one light bulb in it. Well, letter B says we'll draw the circuit light bulb with perpendicular lines. So this will be the last time we use any curves in any drawings of circuits, because circuits always draw with perpendicular lines. So what we're going to do is we're going to make our battery, and then we're going to draw a line that's perpendicular, and I'm going to put a light bulb in my drawing and be perpendicular like this. So this and this are really the same thing. It's just that when we draw a circuit, we always draw at right angles, even though the wires might be curved and going all kinds of places. In fact, my circuit doesn't necessarily show where the battery is, because really I drew it a little bit more like this. Battery down below and light above. It doesn't really matter because I can turn it around. And so there it is. Now, the question, does reversing the wires have any effect on the operation of the light bulb? So, let's find out. So if this is the way we had it set up, but what happens if I take these wires and I switch them? So this goes to here, and this goes to here. Oh, still works. What if I switch them here? I switch here to here, and here to here. It also still works. So, the answer to this question, does reversing the wires have any effect on the operation of the light bulb? The answer is no. Doesn't have an effect. Okay? Does reversing the wires to the battery have any effect on the operation? And we just discovered the answer is no. All right, I'll let you fill that in. It says make a switch. Well, this is what we're going to do. Really, a switch is any time we can open and close a switch, the circuit. So really, that's a switch. But how can I make it so that I've got a switch somewhere else? Well, I could take this circuit and I could make it go to another spring and then bring, so I keep the light bulb connected, and here I could touch it, and now I've just made it so that it has a switch. So when you turn on the lights on the wall and so forth at home, all you're doing is connecting, making the light work, and then disconnecting to turn it off. So in our diagram, we were shown that a switch looks like this. And so let's draw our diagram such that we can make it with a, since we didn't leave much space here, I'm going to do something like this and say, okay, I'm going to put my drawing over here, and that's what I'd like you to do. So I'm going to draw the same circuit with a battery up into the light bulb. Light bulb's a resistor. Then we went to another spot, and really there's nothing to draw because it's still a wire. And then I'm going to draw it open like this and back to the battery. And that's, we had one wire that kind of went to this spot and then onto the battery, and that was our connection. A lot of times they'll draw these with circles to show that that's a switch, because if we draw it closed, we would have a hard time telling if it's a switch. And so we can draw it like this sometimes to show, oh, that's a closed switch, this is an open switch. All right, our next instruction says so use additional wires to connect a second light to the circuit in such a way that it is also lighted. Use a switch to turn the power on and off once the completed wiring has been achieved. Discuss your plans. Then we're going to make a sketch of the circuit diagram. So let's see if we can do that. Now, you're missing out on part of the fun of just discovering this yourself. So I'm going to keep my switch here. Can I connect this in such a way that I can get another light bulb to light? Well, there's several ways I could do this, but I'm going to try it this way first. Put a wire from there to there. So I'm just making this electricity be able to be available here. I'm going to do the same thing from here to here. And there, I connected it. But we did notice the light bulbs went a little dimmer. Well, not really, not any dimmer. a little bit. I think it's because we have batteries that are almost dead. All right, so let's draw a diagram for that. Disconnect my battery. So this time I'm going to take my diagram and I'm going to turn it sideways so that I have my battery coming over here. And I connected a wire that went like this, and this, and then I put 2 light bulbs in here, resistor, resistor, and back together. So that was our instruction there. And now number 5 says, can you devise another way of connecting 2 lights into the same circuit? Sketch the circuit and compare relative brightness. All right, let's see. Well, it's starting to get to be a little bit of a tangled mess of wires. I'm going to see if I can connect it a different way. So what we're going to do is we're going to run the wire from here. We're going to make the electricity go through the light bulb. Then from this wire back to this side. So electricity comes here, goes through the light bulb, comes through here, goes through this light bulb, and back to the battery. And I don't know if you can see, but those light bulbs are barely visible. Can you see that little bit of light? All right, so what we did was we did a circuit like this, where we went light bulb, and back to the battery over here. And these light bulbs were in parallel. This is series. I'm so sorry, but that was wrong to label it the way I did, so please make the correction on your paper and write it correctly, even though you'll see the video continues with the wrong labeling. Everything else about the video is correct, it's just the labeling is wrong. Parallel and series. And here we allow just as much electricity to go this way as this way, and so it stays the same brightness as it did when it was just one battery. One light bulb. Here, we have to lose half of the voltage over this battery light bulb and half of it over this. So that, even though the same amount of electricity, the current goes through here, there's half the push. So here we get to drop out 1.5 volts. Here we drop 0.75 volts and then another 0.75 volts. So there's less voltage. That means we get less brightness, less watts going through that light, and so it is not as bright. So that concludes experiment 1, and our instructions are to clean up. So I'll get to do that for you. So fill in the lab paper and return it.